Okay, good morning, class. Let's go ahead and start with some more FRQs on parametric. All right, so please make sure you have a calculator, because the FRQ that we're going to cover will be a calculator FRQ. So we're going to take a look at FRQ 2015 BC2. Okay. So the particulars of this FRQ says at time t greater than equal to 0, particle moving along a curve and in the xy plane has position x of t, y of t. You are given the velocity vector v of t is equal to cosine of t squared and e to the 0.5t. And you're told at t equal 1, the particle is at the point 3,5. So in other words, x of 1 is equal to 3 and y of 1 is equal to 5. All right. So part A says, find the x-coordinate of the position of the particle at t equals 2. So part A wants us to find x of 2. We're given x of 1. So we're going to use the fundamental theorem of calculus. So x of 2 minus x of 1 is equal to the integral from 1 to 2 of dx dt. And dx dt, which is v of t for the x-coordinate, is cosine of t squared. So if we add x of 1 to both sides, we end up with x of 2 is equal, x of 1 is 3, so 3 plus the integral from 1 to 2 of cosine of t squared dt. So remember, you have to write this out. You can't just plug values into the calculator and come up with answers. All right, so let's go ahead and evaluate this. Everyone has their calculator. Okay. So let's go. We're going to go. So that's 3 plus, then menu calculus integral. We're going to go from 1 to 2, cosine of t squared, so trig cosine, we're going to go t squared dt. So the answer we get is 2.55694. So x of 2 is equal to 2.55694. So that's our solution for part A. All right. Part B says for t between 0 and 1, so 0 less than t, less than 1, there is a point on the curve at which the line tangent to the curve has a slope of 2. At what time is the object at that point? All right. So what we're looking for, so for a tangent line, we're looking to see that dy dx is equal to 2. We want to know the time where this takes place. Well, we know that dy dx is equal to dy dt divided by dx dt. And we're going to set that equal to 2. Well, dy dt is e to the 0.5t divided by dx dt is cosine of t squared. And we're going to set that equal to 2. So that's what we're going to solve. Okay? And we're looking for a value of t that's going to be between 0 and 1. So we've gone over this with our calculator, so let's go ahead and take a look at how we would evaluate that here. All right, so let's go. We're going to go Menu, Algebra, Solve, okay, and fraction bar. So e to the 0.5t over cosine of t squared. We're going to set that equal to 2. Then we're going to go comma t, so with respect to t. Okay, now we're going to go outside of the parentheses, and we're going to evaluate this. We want an answer of t between 0 and 1. So control equal our vertical line, 0, control equal less than t, and less than 1. Enter. And we end up with our answer as t is equal 0.840164. Okay? So dy dx is equal to when t is equal to 0.840164. All right? So that's 2 parts. And we'll take a look at the point distribution in just a sec. Okay, part C says, find the time at which the speed of the particle is equal to 3. So we know the speed of the particle is going to be the square root of dx dt squared plus dy dt squared. And in this particular problem, we want to know when this speed, so this evaluates the speed, we want to know when that is equal to 3. So again, we're looking for a time t. So we're going to do part C kind of like we did with part B. So our speed is going to be the square root. Dx dt is cosine of t squared. We're going to square that. So dx dt squared plus dy dt is e to the 0.5t. And we're going to square that. And then we're going to set that equal to 3. Now, because we're solving for t, we're going to do the algebra solve again, just like we did on the last one. Calculator. All right, so all right, let's see. I guess it's clear enough. So we're going to go Menu, Algebra, Solve. Okay. Now, square root, parentheses, so we're going to get cosine of t squared. Then we're going to square that plus, parentheses, e to the 0.5t, and we're going to square that. All right, and we're going to set that equal to 3. Oh, wait, I'm outside of the parentheses. So equal, oh wait, what happened? That should be squared. That should be squared there. Okay. Get outside of the square root, set that equal to 3, and then comma t. Okay. It's evaluating it. So here, at time t equals 2.1959, that is when our speed is going to equal to 3. So we'll say t is equal to 2.1959. All right. So now this just leaves part D. So for part D, all right, so for part D, find the total distance traveled by the particle from time t equal 1, or t equals 0 to t equal 1. So the total distance, length of our curve, s is equal the integral from 0 to 1 square root of dx dt squared, so it's cosine of t squared plus dy dt squared e to the 0.5 t squared dt. Okay. Now we already have that square root of cosine t squared and e to the 0.5 t squared. We already have that in a calculator. So we're going to try to capture it or cut and paste. That way we don't have to retype it. So we're going to go to Menu, Calculus, Integral, from 0 to 1. And then now let's see if we can grab this. Let's see. It's being, oh, there we go. Almost had it. It might be faster just to type it. Okay. I had it just a second ago. I might have to type it. There we go. So Control C, and now go ahead and come back down here and Control V. So cut and paste, and now dt, and enter. So the total distance traveled is going to be 1.59461. So S is equal 1.59461. Okay. Okay, so here are the scoring guideline, your point distribution. Let's see. All right, so for part A, our points are allotted as follows. There's my red pen. Oh, here we go. All right, so for part A, you're going to get 1 point for the integral, 1 point for using the initial condition, x of 1 is 3, and then you're going to get 1 point for the answer. And they will accept 2.55 or 2.56. 2.556, or 2.557. But as I've said before, whatever you get in your calculator, just write all of that down. So that's 3 points there total. Part B is worth 2 points. So you're going to get 1 point for writing the slope dy dx in terms of t. So dy dx is e to the 0, so dy dt over dx dt. So you get 1 point here, and then you're going to get 1 point for the answer. Okay, so that's 5 points total. We have 4 more to go. For part C, you're going to get 1 point for the speed in terms of t. In other words, you're going to get 1 point for this speed in terms of t, and then you're going to get 1 point for the answer. There. That's 7 out of 9. And then finally for part D, you're going to get 1 point for the integral. Remember, integral means integrand and limits, and then 1 point for the answer. Okay? All right. Ladies and gentlemen, you have 3 more FRQs on this sheet, and then another FRQ sheet that you have. So you're tasked with completing all of these parametric FRQs as much as you can. You may work together. No school tomorrow, no school Monday, and we'll see you on Tuesday. On Tuesday, we're going to go over a practice test for parametric tests for our Unit 8 exam. And then on Wednesday, we will take the test. Is that right? Maybe. We'll have to take a look at our schedule. In any event, have a nice weekend, and I will see you on Tuesday.